show you a few numbers about Spotify so that you get a sense for what kind of large data we're working with, or what kind of big numbers we're working with, and what we have to solve. So on Spotify we have about 191 million fans, 3 million artists, 40 million tracks, and 50,000 tracks are being added every day on the platform. So our users have made about 3 billion playlists on Spotify today. And as of yesterday, we've added 13 new markets in the Middle East and Northern Africa. So we now have 78 markets. So the big data challenge we're facing now is like connecting all those fans to the music that they love, right? And so this is what I set out to do when I first founded the EchoNest. The idea was to basically solve the problem of discovery of music at scale. And not too surprisingly, in 2014, Spotify, which actually was a customer of the EchoNest, acquired the company. And this was actually very good for us because we suddenly were working with the leader and could integrate into the actual service and really address the problem at scale. And soon enough after that, people started noticing that actually Spotify was getting really good at discovery. And it was actually very rewarding for us to see the magic and the power of data being used at scale. So, but first, the first thing you need to do to solve this problem is to actually understand what the content of your the product of your company is. In this case, music. So first thing first, you need to really go after analyzing the music. And so we actually have automated analysis algorithms that go and extract musical information out of the signal, the audio signal. So things like the tempo, the key, the chords, the melody, beats, bars, sections, characteristics of the voice, of the sounds, instruments. We extract tags, we extract the moods, and something that we call subjective attributes, which are the machine-learned musical dimensions that are humanly understandable. So things like energy or danceability, whether the song is live or recorded in the studio, if it's pitch, if it's acoustic, valence, etc., etc. And these are useful as a way to map, organize, understand music at scale. So this is, for example, all the songs that were released by Miles Davis on a 2D map. So you see energy on the y-axis and valence on the x-axis. Valence representing whether the song is happy or sad. And so this is kind of like a mood map of all your songs. So you would have the Miles Davis ballads, melancholic music on the bottom left, and the more upbeat, later Miles Davis on the top right. The size of the dots actually represent whether the song is acoustic or electric. So the smaller the dot, the more electric, and then you can see that the later Miles Davis is more on the top right. And the color represents whether it's it's been recorded live or in the studio. So red being more live, and a prediction of whether its studio is being a bit darker, bluish. But understanding the signal is not enough. You actually need to understand what the culture of music is as well. So what we do is we actually crawl the internet, much like Google does, and extract information through natural language processing out of bios, blogs, news, reviews. We extract descriptors. We understand whether the artist is familiar to our audience. We kind of estimate how hip or hot a particular song is, or a particular artist, when the artist was active, location, sentiment, trends, etc., etc. And so if you start combining the understanding of the culture around music and the acoustics of the songs of the artists, then you can start to understand like concepts, human concepts like jazz fusion. This is a genre, and you can understand like where this artist fit within this particular genre. So here you have Miles Davis and all the artists that are related to Miles Davis. And if you start zooming out, then you can actually connect and relate all the genres with each other. So here on an acoustic kind of map of about 2,200 genres, where like acoustic versus electric is represented on the y-axis, and organic versus more mechanical kind of genres are represented on the x-axis. So this is interesting to to figure out like how to describe music, understand music at scale using data. But now, like the second step, I guess, is you need to also understand your listener, which is your other customer, your other stakeholder. So what we do is like we actually watch what those listeners do on the platform. So for example, how do they name their playlists? So obviously you're going to find a lot of genre playlists like rap, country, house, rock, pop, etc. But what we found out is actually people start naming their playlist with more contextual activities, like chill party. These are the top ones. And in fact, there is next one, okay. And in fact, what we notice is that there's a lot more of those type of playlists on the platform. And so this tells us like that actually streaming changed the behavior and the way people want to consume music today. So here's like the top contextual playlist on Spotify as of like a few years ago. And you can start like grouping them into categories like fitness, mood, travel, romance, time, focus, socializing. And so what this tells us is like context actually is the new genre, is the new way of like really organizing your music and experiencing your music. And not surprisingly, we have a lot of those kind of playlists on Spotify. So for example, running, so not only you can find playlists that are going to be personalized to a particular type of music, a particular genre, but it's also going to be at a particular tempo. So you can actually start running on a playlist and running to the beat of your pace. Another interesting concept that we have at Spotify is the concept of a taste profile. So when we actually look at your history, we can start understanding and clustering your music and make a sort of like a fingerprint of who you are as a listener. So whether you're like to listening to a mainstream music or a diverse type of music, whether you're like more an influencer or like you like discovery, and we kind of start grouping all your music in those clusters. And so here you have like the three kind of pillars of what recommendation is at Spotify. So on one hand, you have the usage data, like what you've been listening to, how you've been creating your playlists, and how you relate to other listeners on Spotify. You have also, going back. Here we're back. Yes, second you have the acoustic information, like I described, and finally like the cultural, the web information that gives you like the semantic and the kind of like meaning of the content of the music. And so this is used to like basically power all sorts of use cases for recommendation of artists, of albums, of songs, like for example a song radio, of various playlists, users, etc. And so one of the big playlists that's very popular on Spotify, you must know, is Discover Weekly, which is basically like 30 songs that are being presented to you every week. But we have a lot of other personalized playlists, including Release Radar and Daily Mix. Daily Mix being like basically radio stations that are created for you on a daily basis and that are clustered by the kind of listening habits that you have. Maybe you're listening a certain type of music in the morning, and there's another type of music at night. This will be very well clustered in Daily Mix. Another one that I think is an interesting way of using data on a platform like Spotify is Fresh Find. So Fresh Find, the way it works is actually for discovery of new artists. So the way this works is we actually, because we can monitor all the users on Spotify, we can find those listeners that have been consistently discovering new artists that became popular. So we kind of make a cluster of those listeners, about 50,000 of them, that are the most, like basically the influencers, the trendsetters, or like the discoverers on Spotify. And then we can basically monitor that group of people and start pulling out the artists that they're listening to now, and will be basically the artists that will be popular in 6 months. So we cluster them into different types of music, different genres, etc. And finally, and last kind of like next level of how to use data, I think is going to be around new experiences. And so I want to go into like 2 examples of what we're doing now that I think is quite interesting and a quite interesting use of having access to a lot of data. So the first one is basically because we have so many tracks that have also instrumentals on the platform, like something like 20,000 or so. We were able to build a model that understands the difference between the original and the instrumental, the difference being the vocals. So with this model, we can build basically a kind of smart filter that can take any track on the platform and in real time will remove the vocals. So if we go to this, so basically like what we did with this is like we built a karaoke kind of mode within Spotify, and in real time we could pick a song and turn it into a karaoke mode. So this is going to be a small video, hopefully there is sound, a small video of this mode that we're now testing in Japan. I'm a little scared. Alright, if you want to play it for like a minute. Nope. No, you don't press. It's a video. Yeah, there you go. There's no sound. Anyway, we can have the sound, or it's not going to work. This is being tested in Japan. Yeah, as you can guess, like Japan is a big lover of karaoke. So yes.
Is it available for every song?
It's yeah. Like right now, obviously there's licensing issues related to this. So like we secured some licensing for the test on some track, but technically it is possible on every song. Yes. On the 4 million song that have vocals. You gotta click on the thing. It's a video. I'll talk a little bit about this then in the meantime. So the other thing that we're doing is actually we're using data to train an AI to help. Yeah, there you go. On the other side, yeah. No.
Team. Yeah. Clay. No.
This paper. Oh, okay. Play. All right. Let's try it. So yeah, so this one is like basically an AI-assisted tool, creation tool for artists. So we're testing with a bunch of artists how we can help them compose music. There. So this is the original, right? Here's the karaoke mode. So you get the idea. And so, yes, so... Yes. So lyrics are synced on the original. And right now, like we do. Not automatically, although that's something we're also doing. Yeah, so it's probably going to be automated very soon. Yeah. So yes, so this one is like, so this is a small team that has been working on creating an AI to help compose music. And we've been working on this with a bunch of artists, some very popular artists, and have been testing this. It's basically a tool to help them create, right? It's like, so when you have a blank page and maybe you have some ideas, maybe at the beginning of a melody, it can help you like generate new content. And that content is being trained on content you may have, or on other content, or very generically. It's basically is getting pretty good at composing melodies, harmonies, rhythms, etc. And so they released an album, which basically are like the work of artists, right? That's called The Hello World, and it's a kind of joke for computer scientists. And yeah, and I want to show you an example of a song that was on the album. So maybe the next slide. So this is composed by the AI, assisted by Stromae. So if you know Stromae is a big artist in France, Belgium, and Europe in general. So he used a lot of composition from Cape Verde to influence what the AI would do. Do you want to play this?